Okay, so
I
let me
hope,
share my screen. Yeah, please.
yeah, I hope everything is back to normal in Dhaka now.
Yeah. So now it's everything normal.
Oh, okay.
Okay, so you also requested for two data set. I will also show you about this. Okay, so before that, first of all, I will
Yeah,
try to explain about our syllabus. Okay, then in the meantime, when I
sure,
take the
sure, sure.
example, then I will show your example. Then it also more better. Okay, so let's at the
Sure,
same time
sure.
we try to complete the two things.
There is some problem in your screen, Mr. Rahman.
Yeah. So now is it okay?
Now I see multiple screens. Ah,
Ah,
yeah,
yeah.
now it's fine.
So now it's done. Yes. Okay, so basically, for introduction to remote sensing and satellite data. So in the example, I will show you that how we can easily get the LST or vapor data or other types of data, how we can easily get for a specific boundary and then create the map or time series chart. We also try to discuss about that, as well as also common Landsat, Sentinel or MODIS data. So this type of data set we can easily access a lot of information such as vapor information or actual EPOPO transportation data, or a lot of data we can easily get it from the MODIS product. It provides a lot of data so we can easily access, and talk about that how we can easily visualize this type of data or satellite imagery, how we can easily filtering our data for our specific time or location or cloud cover, and finally image maxing, then clipping and reducing, and finally how we can easily export this type of image from our Google Earth Engine Python API. Okay, and from the third number of class we start for the machine learning. Basically this is the basic things about that, and then we from the third number of class we talk about the machine learning and different types of machine learning method, how we can easily apply and make the classification or regression. Okay, then we talk about the further. Okay, so let's go. So first of all, the okay, let me open my slide. So first of all, remotely sensed data. So basically, we can easily get the remotely sensed data from satellite, then aerial photography or drone photography. So different types of uh, medium we can use, and then we can easily extract the different types of satellite imagery. Okay, for the large area, all time we use here the satellite imagery for the large area. When you cover, suppose at the same time for whole country boundary of Bangladesh you want to observe, then we have to use the satellite imagery. But for the small study area, such as for a cropland or a small urban area, then we can easily get the satellite, or we can easily use the drone imagery or aerial photography we can easily use, because for the small study area we can easily get the very high resolution imagery, and further we can easily use it for our remote sensing analysis. So the in this time we just concern about that satellite data, because we make the map for the large boundary area, but we are also providing that another online training program such as how we can easily handle the drone imagery or aerial photography. Okay, basically there are a lot of uses in at present time to use the aerial photography or drone imagery. So basically remote sensing, we already know about that. Remote sensing is the science of acquiring information about the earth's surface without actual being in contact with that, and basically this is done by using sensing. This is the basic things about that. So basically this is the common framework for the remote sensing process. So in the remote sensing, first of all we need a source. Okay, so basically or passive. So here you can see in this time, in this figure we can easily find out the energy source. It suppose sun. Okay, sun provide the electromagnetic radiation. Okay, so this is the main source. Okay, from we can easily get the electromagnetic radiation. And also you can see about that B mainly atmosphere. Okay, this is the atmosphere. And then C mainly our target object. Okay, so this is the interaction with the target. So in this time, first of all, from the source, main source, it reflected or emitted the energy from the sun. Okay, it recording. Also you can say about the another things. This is the D. So basically after reflection, recording the energy of the sensor. So this is the sensor. So this sensor can be satellite imagery or drone imagery or any other platform. Okay, so this is the sensor. And also you can see about that E. So basically this is the transmission or reception or processing the data. And further in this time we can get the interpretation analysis. And after when we can get the imagery from the satellite sensor, then we can easily apply the different types of method. And further we can easily extract the different types of information such as land surface temperature or land use, land cover mapping. We can easily do a lot of things when we can get this satellite imagery. So this is the common platform of remote sensing. It must be need the energy source. Okay, so basically satellite imagery, we are use the energy source as a sun, but as well as we also use the different types of LiDAR imagery. So LiDAR mainly one's kind of platform. This platform send the radiation from own self. Okay, so it's the passive remote sensing. So in this time we talk about only for that active remote sensing. Just we are just use the satellite imagery. Okay. So I also send you this type of things. You also read, then you can read a lot of information. Okay. So basically we can use at the different types of platform classification based on platform, airborne remote sensing, spaceborne remote sensing, also active remote sensing, passive remote sensing. So these are the different types of remote sensing based on the platform, based on the energy source, based on the imaging media. Okay, and this is a lot of advantage of using the remote sensing. So basically we are using the remote sensing for land use mapping, then forest and agriculture application, then telecommunication planning, environmental application, hydrology and coastal mapping, urban planning, emergencies and hazards, global change and methodology. So not only for that, that the lot of application is available. Also you can say about the urbanization and transportation. So there are a lot of uses. Also agriculture for soil sensing, farm classification, farm condition assessment, agriculture estimation, mapping. There are a lot of things about that, or natural resource management. Okay, so there are a lot of uses. So now we talk about that how we can easily get the remotely sensed data. Okay, so in Google Earth Engine platform, basically in Google Earth Engine platform, we can easily get the different types of data from the Earth Engine public data catalog. So this is the Earth Engine public data catalog. We can easily access the different types of Moody's data, Landsat data, Sentinel data, lot of data, so we can easily access. Okay, suppose when you need any data, you can simply search here. Suppose you need the vapor data or LST data. Suppose I simply search here, vapor. Okay, then click to the run. So now it show me all of suggested vapor data where we can easily get it from the Google Earth Engine dataset. So here you can see it show me about that the water vapor Earth Engine data. Also you can see the vapor in Earth Engine. So it suggested me different types of data. Suppose I want to work for the water vapor. Just click on the water vapor. So now we check about the all of information about this data set. So basically this is the NCAR reanalysis data. It's the water vapor. And this data set is availability. We can get the data from 1948 to 2024. Okay, so very long first time we can easily get it from here. The water vapor. And this is the data. And you can see about that, this is the unit about that, kg per meter square. Okay, and this is the total column water vapor. Okay, this resolution is not much good because you can see this pixel area is very high. Okay, so it's this resolution is much good, but we can get the data set very long first time. You can see about the all of discussion about the data set, how they create this data. Okay, so you can see about all of information. Suppose now I want to use this data and try to make the map, and this data set is the globally available, so that's why you can easily use it and make the water vapor map, and it's available from 1948 to 2024. Very long time period, you can easily get it.
Mr. Rahman.
Yeah.
Mr. Rahman, I just wanted to know, I mean, the potential evaporation data from this this site, like Water Productivity Open Access Portal, WAPOR.
Yes.
Do we have in GE?
Okay, so let me check that it is available or not. So his data
Yeah.
W
Yeah,
F
WAPOR. It
upward.
is
Yeah. Yeah.
water productivity open access portal.
A data set in Google Earth. We simply search on the Google. If it available, then we can easily use it from here also. Okay.
Yeah, see, open data now accessible from
Yeah.
Earth
Proper
Engine.
data now accessible from the Earth Engine. Okay, so this data set is now also available from Earth Engine or part. Yeah, so it also available. So 250-meter
Yeah, great.
resolution. It also high.
250 meter.
Yeah, so that's why you can easily get the more better result. So here you can see about that vapor net primary production, daily evapotranspiration. Suppose I click on
Yeah,
here.
you can go there.
Yeah, so it also available. Okay, vapor daily reference,
Oh,
evapotranspiration.
great.
Yeah, yeah. So we can get the data set from 2009 to 2023 03 this time.
Uh-huh.
Okay, so
Can we prepare for this, Mr. Rahman?
okay, no problem. Okay. Okay, so it's easy.
Yeah.
We can easily do it. So this is the data set. We can also use it and make the
Yeah. Okay.
evapotranspiration. Okay, so I simply copy. And if you want, you can also use it the Python API or Google Earth Engine code editor. Both are the same. Okay, just I write the code in the Google Earth Engine JavaScript API. We try
No.
to
Yeah.
use. Okay.
Yeah. Google Earth Engine. Yes. Java.
Okay, just paste here this snippet ID, and further just take a variable. Suppose I put the variable name is that data set. You can
Wow.
vary name. Okay.
Okay.
So now, first of all, this data set have a band. Okay. So this band we have to select. So just use at the select function, and then you can see about that your data set band. Data set band. Here you can see about that. This simply copy this band name and then further paste here. Okay, and now just put your time period. So which time you want to observe this data. So use at the filter date function and put your time. Okay, suppose I want to put this time 2020.
Yes.
Suppose 1st January from I take the 1 year data. Suppose 2020 December 31. So this is my time period. So now if you want to check about that, suppose how much images are available between this time. So just put the data set and use at the size function. So now it computing how many images are available between this time. We can get the 365. So it's the daily
So
data.
daily
Daily data. So
daily
that's
one.
why that's why we can every single day we got a one image. Okay, so this is the daily data. We can easily get it from here. And further, suppose I want to visualize this data, or I want to make the time series chart. If I make the time series chart, then I can get what is the unit. This unit is the millimeter. Okay, this unit is the millimeter, and you can see here this data set have a scale. Okay, so basically when you find out this type of scale, any data set, not only for that, any data set, this scale value we have to multiply with our images. All of
Okay.
images we need to multiply. Then we can get the proper pixel value of this data set. Well, 0.1. So this is the scale of this data set. We simply multiply. So for multiply, just I make a function. Just use at the map and use at the function keyword and put the element name suppose image. And further in this curly bracket, just my argument. My argument is that I just return this image, return this image, multiply with 0.1, and I want to apply all of imagery, total 365. So just I use at the copy properties function I copy these properties from this image and apply system time start to system time in. Okay, so now it will apply. And now if I make the time series chart, or if I make the map, then I can get the correctly pixel of water of evapotranspiration. We can get the correctly pixel. So now suppose I want to visualize this map. Suppose I want to visualize
Yeah.
it for your study area,
Visualize,
and
yes.
then check the result.
Fujairah boundary.
Yeah, so this is
Yeah,
the
Fujairah. Yeah, Fujairah Emirate. Fujairah
okay,
Emirate
yes,
is there, no? FUJ.
so this one,
Yeah.
just
Yeah,
import,
that one.
and I put this name, suppose
ROI.
ROI. And so now I want to make this time series chart. So basically, when you make the time series chart, then just
No. We'll display the map first.
okay. For displaying the map, just take a variable. So basically, when I make the map, so these 365 images I need to combine. Okay.
Yes. That
Because
will be average of
yeah,
1 year.
yeah. So further, we have to calculate the average. We calculate the average from total 365 images. So just I put the variable, suppose mean et, and then I just call this data set, and then just use a mean function, and further clip with my study area, which is ROI. So now display this
ROI.
result. Just map dot add layer,
Add layer.
and then call this mean et. Simply copy
Mean
that and
ET.
paste here.
Right.
And also center view of this your boundary shape file. Just use and map to the center object and call your ROI. So now it directly focus on your study area, and also load the layer. So now it loaded. Okay, we can get the gray color map because we not add any kind of color. So we are just add the color. Then we can get the more better map. And okay, so in this time they're not use any kind of color code. Okay, so we randomly put the color. Okay, so for adding the randomly color, just I click on here, and then stressing suppose 98%, and further we try to add the color combination. Suppose just click on here, plate it, and where is the low I want to show, suppose this type of color indicating the low. Then greater than I want to show this type of okay, so or you can also put here, suppose low, suppose red, then greater than suppose yellow, suppose greater than suppose green. It is the high evapotranspiration. Then apply it. So now it will be loaded. Okay, so now here you can see we can get this type of pixel. Okay, so now you can see here this map is not mass, is smooth. It show about that pixel. Okay, so basically you can get the grid because this resolution is not much good. This pixel area is very high. We can find out the pixel area. You can see 80,924 meters. So that's why we can get this type of result as a grid. Okay, as a grid. Suppose we find out that it show about that high value about that. Okay, so that's why this data set is okay when you apply it for the big study area. Okay, suppose whole country boundary of the Argomirat, then we can easily get that more better result.
But Mr. Rahman, when we are starting it, in the data sheet, it says it is around 250 meter resolution. See, once open that catalog.
Yeah, okay, just a minute. Let me check. Okay, so I think it's the another data set or daily vapor reference evapotranspiration.
See, just see.
Yeah,
Continental level resolution 250 meter.
Yeah, so it also okay. Just click on here. Okay, the new set of vapor data now accessible for Earth Engine are part of the confidential level resolution at the and actual evaporation. Okay, so net primary production. Okay, so vapor Okay, so let me check all of our data set and
I
it's more
think
better.
down you have something.
I think some networking issue. Let's search here. Okay, so we can get this data. We already check it. Reference evapotranspiration 2.0. So we try to check the actual this data set. Just like open it. So this data, check the yeah. So this is the okay. So this is the data. Yeah. So this is the I think this is the correct data about that. We can get the 248.2 meters, and this is the
Yeah, I think
actual
we have to replace
evapotranspiration.
this one.
Yeah, yeah. So just simply
Snippet,
replace it.
snippet.
Then we can get that more better result. Simply copy this snippet ID from here, and then just change it. Just simply paste here, and also check the band name about this data set. So this is the band name, and scale is the same 0.1. So just simply change the band name also. Okay, so now try to run the code again. So now I hope we can get the more better map. And now set the color. Okay, so let me check if they're provide any color or not. Okay, so it's also not provide any color. So just we set the random color. Just click on here.
Yeah.
Okay, just apply. Suppose to show this type of yellow. Greater than show about that. Then put at that high. This type of green color and apply. Okay, so now it also more better map. We can get it. So here you can see we can get this type of result. So mainly this type of green color identify about that high net evapotranspiration result. We can find out from here this type of green color. Okay, suppose if you want to check the other stressing level, suppose click on here. Suppose I want to check 90% stressing and check the visualization. Just apply. So now I can get this type of things. Suppose stressing 3 sigma. Okay, so now we can get this type of map here, you can see. So I think it look more better. We can easily get it this type of green color. Identify about that high evapotranspiration value. Okay, just simply import and further copy this ID from here. So here you can see about that. Just simply copy this variable name and paste after the object name. I put the ED. Okay? And this unit is the millimeter. Evapotranspiration unit is the millimeter. And further we can easily export and make it map for arc power users. As well as if you want to check about the time series chart when it will be high or low, this data set we can also check it from here. Yeah. Okay, so do you have any question?
Yeah, it's fine, Mr. Rahman. We can also keep the output function, no? Yani export.
Yeah, yeah.
Export
Okay, so
to
for
drive.
exporting, it's very easy. Just we put here that
Yeah.
Export image to drive.
To drive.
So we export it in our drive. So that's why you can easily get the tip image. Further, you can easily make the map using ArcMap. So first of all, image mainly it's our which I downloaded. I have downloaded these things.
Yeah, mean
It. And description we can put anything as a variable. I put this suppose ET 2020 folder. You can put any name. Suppose G file name is not remove that. Region is a shape file variable name which is RY. Scale is the resolution. Put here the 250 meter. Another not remove that. Now click the run. and further
Oh, you
just
will get 36 images.
yeah for 1 year. Okay, so it's about,
No,
I think it's not daily. This data set is not daily. So that's why we can get the 36 imagery. Okay, so this data set is not daily. Okay, so the acceleration and return, okay, millimeter per day. Okay, it's also show about the millimeter per day.
I think we have already
Uh,
done for mean. We have given that code as mean, Mr. Rahman. That is
Means,
average.
yeah, we calculate the average. This total
Huh.
36, we just average and create this type of things for 1 year.
Okay. Okay.
Now, if you want to check the value, suppose click on here and click on this value. Suppose just I click on here, then we can easily get it. What is the value? 1.8 millimeter for this
Okay.
coordinate. We can get it from here. Click on here.
So,
2.00.
so
Okay.
we will be getting this image, no? This image
Yes. Yeah.
output.
And from this
Due
tax
to
tab, we can easily get that output, run that, and we can easily
ah
make the map using our proper uses for the presentation.
ah
Yeah.
okay, okay.
Now, the same process also for LST or any data set in Google Earth Engine platform when you work. So this is the same
Yeah, yeah.
process.
Actually, Mr. Rahman, I wanted to know the temperature and what you call stressed rainfall deficit.
Okay.
Huh. Showing the rainfall and the rainfall deficit.
Okay. For the rainfall density, what's the algorithm we have to put in here? Mainly less rainfall region. We find out.
Yeah. First, we'll map the rainfall from the chirps data,
Yeah.
and then from there, rainfall deficit map.
Okay, so is there any parameter, suppose less than 100 millimeter, then we can consider it as a rainfall deficit region? Is there any parameter? I think we have to apply a thresholding value and then
Uh-huh.
further identify about the rainfall deficit region.
Okay, we can say less than say 20 mm.
Okay, so we try to check it. Just simply search
Uh,
here in the charts. So here you can see about we can get the daily or painted. Which one is better, daily or painted?
chirps data daily,
Okay, let's click on the daily.
and we'll do mean.
Yeah. Okay, no problem. So this is the daily data set about the SERPs, climate hazard, central infrared precipitation with the station data. So this data set we can easily use. So further simply copy the same way. Just simply copy, or you can let me open a new code editor. Or if you want, you can also use the same code editor. It was no problem. At the same time, we can create the two layer. One is key property and another is for precipitation. So charts, just paste here. The name and give a name. Suppose I put the name is that rainfall data set, or you can put any name as a rain. Okay. So now this image collection have already have a band. So try to find out this band. Over here you can see about this. This band name is that precipitation. Okay, and it provides the data millimeter per day. Okay, so just select this band. So just use that the select and put this band name. So further same as just put the time period. This time you want to observe for the data. So just paste here this data. So just paste here, just put here the filter date function and put this time period. So just put the time period. Suppose I put this time year of 2020. Suppose 1st January from year of 2020 December 31. Okay, so this is my time period. So if you want to check about that, how much image we can get it. It's a daily, so that's why we can get the image for total 365 for daily data set. So now try to check it. So now click the run. So we can check about we can get 365 imagery for the daily data set. So further, just take a variable. Suppose I put the variable name is that mean precipitation or mean rainfall. You can put any variable name, rainfall. So mean rainfall, and call the rainfall data set, and then simply use at the mean function, and it clip with our study area. So just clip with our RY. So now further map dot add layer and call this mean rainfall and paste it on. So now we can easily get this result for this rainfall map. It also loaded.
Yeah,
Without color.
We'll off the ET map.
Yeah. Suppose we are just add here the color, just same as stressing 98%. And I want to show, suppose where is the less rainfall, I want to show this type of red color, and where is that then yellow, and get it, then I want to show suppose blue color for that, then apply. So now we can get this type of map. Okay, so you can get the grid. You can see, you can get the grid or cell, because this resolution is not much good. So this resolution is that 5,566 meters.
Yes, that is 500.
So that's
meters,
why we can get this type of mapping.
Kilometers.
Yeah. And so I put the stressing 3 and then check the, just apply. So now we can get this type of visualization. So here we find out that the red color identify about that high, low efficiency. So basically this type of region is the low precipitation, okay, or low rainfall, this type of region. Okay, so this is the high, this type of green color identify about the high, and this is the medium. Okay, this is the medium, but this type of region identify about that very less precipitation. Okay, or rainfall or precipitation dependency region, you can easily find out this type of region. And this unit is that millimeter. Okay, this unit is the millimeter. You can check it. Suppose just click on here.
The range is from 173 to 361 mm.
Yeah, so this range, okay, so it also suppose 0.1. Suppose this type of red color identify about the 0.1 or less than 0.1. Okay, and 0.3.
What is the actual value, Mr. Rahman? Like,
so
what is the value for mm?
Okay, so further to check it, suppose I just click on the red color, then we can get about that. You can see the value is that 0.2. Okay, 0.2. But when I check about that this type of pixel, it show about the value for 0.3. Okay,
3.
Yellow, you can see about that 0.26. Okay. Also, you can see this type of
what is the actual value, Mr. Rahman, in mm?
Or average or maximum. Okay, so for that we also need to calculate. Suppose in this time this value it only for the stressing, but it not show about the mean and max value. We can also calculate the mean and max value for our specific study area. So now I will show you that just a minute. Just simply import the visualization and copy and paste after the object name. So just this is my object name. I paste and I put here that rainfall. Okay, this line. So now we check about that. What is the maximum value of precipitation or rainfall value? Maximum rainfall. So for that, just take the variable. Suppose a max rainfall. So just call your map. So this is my map, and paste here, and then use at the reduce region function. Okay. So it computed how much, what is the maximum rainfall for this time and now I want to just curly bracket star and also curly bracket end. So then for the reducer, I want to calculate the maximum rainfall. So user EE dot reducer dot max. Okay, it calculates the maximum for my study area, which is RY. Scale is that 5,600. Suppose what is that? 5,600. 5,566.
556.
Just put here. And others not need, remove that. So now it computed what is that maximum rainfall value for this study area. We can easily get this statistic value from here. So run, click to run. So now from this console tab, we can easily get this result as a object. Click on here. We find out that 0.33. It's a maximum rainfall, 0.33 millimeter. Okay, within this time, it's the millimeter. Suppose I want to check about the minimum rainfall. Just paste here, and I want to check it. Just simply change it. Suppose I put the variable name as that mean rainfall, and put here that mean, and then further copy the mean rainfall and paste here. So now it computed about that minimum rainfall for my study area in year of 2020. So we can check the result. We can get the 0.2. Okay, so this is the minimum rainfall and this is the maximum rainfall we find out from our map. Okay, and this is the visualization. We can get it look like that. Okay, and when you export it, same code we have to use in here. Yeah. So this is the code.
And here rainfall deficit. Mr. Rahman.
Okay, so for rainfall deficit, we have to use a algorithm. Okay, just a minute. Let me check some algorithm about that, and then try to implement. And basically, it's also better to use basically in year of 2020. Suppose I want to calculate the total rainfall. Okay, suppose I want to check about the total rainfall, and from this total rainfall, I want to just check take a value. Okay, and then further we are just find out that suppose in this time without mean, if you want, you can also put here that sum function. Okay, so now it will be calculated total 365 all of pixel of rainfall or precipitation. It calculate the total. Okay, make the total. So now we can get that total rainfall between this time year of 2020. Okay, so it also better to use the calculate the total rainfall or total rainfall calculation. We are just using the sum function, then the daily rainfall images to get the total rainfall over the period of time in 2020. Okay, so it also better to use. You can also use, suppose just use the sum, then we can get the total rainfall. So let's click on here. So now it shows about the total rainfall in 2020. So now we can get it. Suppose just now this map show about that total rainfall map in year of 2020. So just click on here. Okay, just apply. So now it show about the total rainfall. Okay, so basically for the rainfall, we calculate the total rainfall over a specific period of time. And when you find out that less rainfall area or rainfall deficit area, so further we have to apply a thresholding value. Okay, suppose any specific, suppose less than 0.2, suppose less than 0.2, all of pixel we can just consider as a rainfall deficit area.
Rainfall deficit.
Yeah, so further we are just set a thresholding value, then we can easily get it. Suppose I will show you that. Suppose just take a variable. Suppose we just set a so it's vary from region to region. Suppose in this time we consider about that less than 0.2. Suppose less than 0.2, all of region we consider about that rainfall deficit area. So for that, just take a variable. I put the variable name, suppose threshold. Okay, in this threshold value I just simply put the 0.2. Okay, all of value greater than 0.2 I consider as a rainfall deficit area. So now just I take a variable. Suppose I put the variable name is that less rainfall. Okay, and then I simply call the total rainfall. Okay, so I already make the total rainfall map. So you can see I just use here that sum. Okay, sorry, it will be sum, because from the total rainfall we consider less than 0.2 as a rainfall deficit area. So just calculate the total rainfall. Just I put it the sum, then it calculate the total rainfall. So click to the run again. Okay, just I commenting these things and run it. So now we can get the total rainfall map between this year of 2020. So here you can see about that this is the this variable stated the total rainfall. Okay, and it should look like these things because we have to change it. Suppose click on here the rainfall and stressing 98%, and further here you can see now we can get the more better value. Okay, so it calculate the total rainfall 73.120 millimeter. Between this time we get it this type of value. Okay,
Yeah,
but when
this
I
is what I'm
calculate
looking for, Mr.
yeah,
Raman. Yeah.
yeah. So that's why rainfall, when you calculate, we calculate the total rainfall. So just put here the sum. So now suppose we set a value. Suppose suppose 100. Suppose less than 100 millimeter rainfall we consider as the rainfall deficit area. Okay. So that's why we are just suppose I just import the visualization first. Otherwise it will be gone. So just I simply copy this variable. And further just I change it. So now we can get that total rainfall map, and from the total rainfall we just find out that less rainfall area, and our thresholding value suppose 100, less than 100 millimeter rain we consider as a rainfall deficit area, or it will be vary region to region, it will be vary. Okay, so just take a variable. I put the variable less rainfall area, or you can put any variable name, and then call the total rainfall. Okay, basically here you can see this total rainfall is sum. It is stored in this variable mean rainfall. I simply copy the total rainfall variable and then paste here. Okay, then use here that just put here the less than function, mainly LT. It is that less than LT. And I call the thresholding value. Thresholding is the 100. So simply copy, because 100 is stored in the threshold. Okay. So now further we are just show the result for less rainfall areas. So just add here map.add layer, and then call that less rainfall, copy, and then paste. And further just use here the update marks. Just put here that update marks function, and I want to update marks using this condition, basically less rainfall. I simply copy and paste here. Okay, and further just put a plated. Suppose I want to show this type of region as a suppose red color. Suppose put here the plated, I put the color as a red. Okay, and further I put this, suppose it's a suppose less rainfall. Okay, so now further click the run. So now it added the another layer. Okay, so click the run again. Okay, so now we can get this type of, you can see this another layer. This type of region show as a your rainfall deficit area. Okay, so we can get that lower 100 mm region. Okay, so this is our map. This type of region we can get it. Okay, this is the rainfall deficit area.
We can also change the parameter like less than
Yeah. So it's you can easily
20.
change it. Suppose basically it's a vary. So for that you can simply change in here. Suppose you can see about that 100. You can simply put here the suppose less than 70 or
Yeah,
50.
50.
Okay, run the code again. So now we can get it less than 15 all of region, which is indicating about that less rainfall region. Okay, so now here you can see, just I open this. Wait about that less than 50. Okay, is not available. We have to increase the value. Suppose.
Okay. It's not available there.
Yeah, so you can see your maximum precipitation is 74. Okay, and it is the minimum. Minimum is the 74, and it is the
Yes,
121 is the maximum. So suppose just put here that 75. So now we can get the pixel. So now, so we can get this type of place. Okay, red color. Okay. So that's why you just simply increase the value. Then we also get more. Suppose I put here that 90%, 90. Okay, so now I can get this type of red color. Okay, so you can see this type of red color identify about that rainfall deficit area. Okay, because it's a less than 90%, 90 millimeter rainfall between this time, year of 2020. Yeah. Okay, so this is the process about that. You can easily apply the thresholding and you can easily check about the rainfall deficit area.
Yeah, okay. So in this red, we can't get more colors.
Uh, these things, this red color, yeah. Okay, no, because in this time it show about that all of pixel show as the same color. So all of pixel which is less than 90, it show about this type of color. Okay.
Okay.
And this is our main total rainfall. You can see this is the total rainfall map. This is our total rainfall. And this is our deficit area from this rainfall. We can get it. This type of region is the less than 90 millimeter rainfall. This type of red color. And this is our final total rainfall. Okay. From this total rainfall, we derive it for the less rainfall region. We find out this type of map.
Oh, okay, Mr. Raman.
Okay, so now any question?
Yeah, it's fine, Mr. Raman. I totally understood this. I think I will work on this. And last time we sort of soil texture also we have done, no?
Yeah. So this code is already available in Google Classroom. You can easily get it.
Soil texture.
Yeah. So I already uploaded.
Soil texture. So rainfall, temperature, soil texture. Is it available here, Raman?
Which one?
Soil texture.
Soil texture, I already sent you this code, and we already performed the analysis. Soil texture mainly USDA data set. We can easily this data we can already work USDA. Okay, so this is the soil texture class. We already
1 to
okay, clay,
2017.
silt clay or sandy clay loam. Okay, silt
Yeah,
clay loam,
yeah,
sandy clay loam.
yeah.
It already done. Yeah.
So if it all it's not done also, I mean, if it is not there, I will just take the snippet and do the process, same process.
Yeah. Yes. Same process. In Google Earth
Yeah.
Engine, all of data set we can easily handle as the same process. Okay. It not
Take the
much
snippet.
difference.
Yeah, take the snippet and yeah, it is 30-meter resolution. Oh, okay.
Yeah.
And the bands, please come down, Sulaiman.
Yeah.
Scroll down.
Band we can get the two band. One is the 0 to 20 centimeter depth. Another is
Uh-huh.
that 20 to 50 centimeter depth.
Oh, we have both the snippets there.
Yes.
Where Earth Engine snippet, one is that one is for
Okay. So
oh,
basically, this is the image, and
oh,
this
we
image
have to
have
name.
two band.
Okay, I understood.
Okay. This is the
Yes,
two
yes.
band.
Yeah, these are the
So
two
which band you want
variables.
to use?
Yes.
Just simply select, and then you can easily make the map.
Okay. Yeah.
And
This is in
so this is the another way is that this data set is not only for the Africa.
oh, this
Okay.
is only for Africa.
Yeah. So that's why it's very low. You can get the high resolution. Okay. So basically this data set, but we also use the another data for the soil texture. It also available for that. Okay. So this is the so this is the USDS system. This data set previous I also show you that. Okay. So this is that open land soil texture class. Okay, so basically in this data set you also get this type of band. Here you can see B0, it is the 0 centimeter depth. B10, it is the 10 centimeter depth. B30, we can get the 30 meter centimeter depth. And all of classes you can see for the B0, we can get the clay, then sand clay or clay loam. So all of classes, okay, we can easily get it from here. So
Okay.
this data
This is
set I already use and show you
open
the,
land map soil texture.
this is the open land soil texture. And it's globally available.
Oh, okay. And this doesn't have two variables, no? There's only one variable.
Yeah.
Only one snippet, and then okay, for each band we can
Yeah. Suppose you need the 0 centimeter depth, simply select the B0 and then you can
B0.
work with that. Yeah. Then you can get the
Okay.
0
If you
centimeter
want
depth
B10,
soil class.
10 meter, 10 centimeter
Yeah.
depth, we have to do it.
Yeah.
Okay.
Yeah. Yeah. So this way I already send you.
Ask him.
Okay. So now I hope everything is good. Yeah. Any question or I continue?
Yeah, it's fine. It's thank you so much, Mr. Rahman.
Okay. Okay. Thank you. Okay. Okay. Yeah.
Just just
Please.
send me this code, get
Okay. I'll
link.
also send you in our Google Classroom. You can easily
Yeah.
get it from here.
Aye. Or you can send me in my Gmail.
Okay. I'll send you. No problem.
Yeah. Okay. And then for our the Python thing, can we uh, can we make it on next Tuesday again?
Okay, so basically, so actually we have also short time about that. So it's a total 7 days online training program. We providing this type of things. Today is the second days.
Yeah.
Also, I continue the second days also, no problem. And but it's not very big, so I already write the code. Just explain, then I will send you the code link. No problem. Okay.
Okay, Mr.
So,
Rahman.
so previous class we discussed about that how we can easily install the GE map, and
Yeah.
then as well as how we can easily.
Keep
Okay, so I'll
install.
show you that.
Yeah.
Yeah. And further, simply connecting. As I simply import the GE map,
Ah.
and also import the Art Engine, and then authenticate with our Gmail account, which is already created for the Google Earth Engine account. So now, okay, just simply sign in. Just continue.
Actually, one small doubt, Mr. Rahman.
Yeah,
Like
please.
using our Google Earth engine only, we cannot do deep learning algorithms like ANN and
No,
CNN.
no. So this CNN or ANN, we have to use the Python API. Okay, so that's why this is our new course. Basically,
Uh-huh.
CNN or deep learning is also possible in Google Earth Engine, but for that we have to pay the Google Earth Engine authority. But when you integrate the Google Earth Engine with Python API, then we can easily use the Python library and we can easily develop the deep learning or CNN and make the
Okay.
classification. Okay, so for this freely use for the deep learning with Python integration with Google Earth Engine, so that's why we are public this online training program. In this online training program we are mainly focus how we can easily use the freely deep learning integrate with Google Earth Engine. Okay, so let's go. It's also possible the Earth Engine code editor also, but it's not free. But in Python, we can easily use it the deep learning freely integration with the Google Earth Engine Python API. Okay, so further here you can see we can just simply talk about the map. So GE map, this is the Python package. This map is already stored the Google Earth Engine. All of package it's stored in here. So we also add the base map. So previous class we are not add the base map. So here you can see we can easily add the base map. This type of base map we can easily add. So just map dot add base map, then we put here the base map name. Suppose history world imagery we can easily use in here, and then we can easily get the result. Also you can say about that open topo map. Open topo map we can also use in here, and then we can also get, suppose here you can see we can easily get about that history world imagery and then open topo map. We can get the two layer in here. Okay, suppose let me run the code. So here you can see we can get this type of base map. Okay, so when you add, suppose add base map, so different types of base map is available. So here I show you two example. History world imagery. So we can get that OpenStreet as a default. Okay, we can get this base map as a default. But when you add, so we can see this is the open topography base map, as well as also you can see about that world imagery. This is the world imagery, mainly satellite view. We can easily get it from here. Also, you can say about the OpenStreet. So OpenStreet map is the default. This map is default. So first time he will show you that we can get this type of map, but as well as we can also add some base map. So here you can see the history world base map or open topographic map. So for that, simply call this map variable and use at the add base map function and put your base map name. Then it will be added with your map. So now we can get the history world imagery map as well also open topographic map. We can easily add as a base map. Okay, so as well as we already discussed about this code, how we can easily get that EBABO transpiration. Okay, the same process we can also apply for that. So just I show you this thing. Suppose just I run the code. Okay, so this part is complete for the first day. How we can easily add the map for that EBABO transpiration. Okay, just I run the code again. So just try open this. So here you can see we already discussed about these things, how we can easily create this type of map. Basically, EBABO transfer or any data set is the same process for creating the map. So here you can see. Okay, so this map, how I can export from Google Earth Engine Python API. Okay, so here you can see this is the EBABO transpiration map. We can generate it. If you want, you can also change the base map. Suppose you can see that you can put at the history imagery. So now we can get that the satellite view base map. Suppose I just put here the open topographic map. Just click on here. So now it shows about the open topographic map or any other base map you can easily use in here. So just I use it the same. satellite imagery, world imagery. And further, we are just, okay, so we already talked about that. As well as you can see about that Landsat imagery, we already imported for your study area, Fuji Emirat. So then we are just visualize this map. And further, we also make the NDVI for your study area. And also run this code. Okay, so this is the NDVI map show for your study area. We can get this type of map, NDVI map. Okay, so from this NDVI map, we are also applying the thresholding technique. Suppose just put here that specific thresholding technique, and we extract the vegetation from here. So just we try to export. Suppose greater than all of things we consider as a vegetation. So for that, just NDVI greater than 0.3. So all of pixel of NDVI greater than 0.3 we consider as a vegetation and show as a blue green color. So here you can see this type of green color, identify about that vegetation, and it's the greater than 0.3. We can easily get it from here, applying the thresholding value. So now we talk about the exporting, how we can easily exporting the data such as this type of map or this type of satellite imagery, how we can easily export. We try to discuss about that. For exporting, just suppose you can see here, this is one kind of image, so Landsat image. I select the band B4, B3, B2, and this is my area of interest. I take the rectangle. Suppose this is my rectangle. So now I want to export it. For exporting, we are just put here the e.base export image to drive. Okay, this is the function all time. For the Python, we are just put here e.base export image to drive. Okay, this function when I just put here the image, so basically this image just clip with my, this is my variable name, and clip with my study area, then description just I put any name, resolution 30 meter, then region of interest is the ROI, file format is the geotip. Okay, then I put the folder name G export, then start the export task. So just when I click the run, here you can see it will be run the code, but where I find out the status about that exporting. So you can easily get it from your code editor. So here you can see in the code editor, in the task bar, we can get, it will be starting. So here you can see, so you can see it will be starting. Okay, but it runs from Google Earth Engine Python API. Okay, so we can easily check the status from here. Okay, so now you can see it will be loaded. So it takes some time, then we can easily get this imagery, but it running from our Python API from here. From here and run it, then it can easily get the status from here. What the situation for that?
Mr. Rahman.
Yeah, please.
I know I've got some little work. I need to go out.
Okay. So no problem. I will send you this code, full code. You also try to check it, and further if there's any problem, then we talk about the third number of class. Okay, so you try to run the code one by one. So I hope we can easily get this idea how to work. Okay, thank you. Okay.
Sure. Thank you, Mr. Rahman. And the earlier code also please send me.
Okay, I'll send you. Okay, I'll send you in the.
I will run through it again.
Okay, thank you. Okay, have a good.
Please, thank you so much, Mr. Rahman.
Okay, thank you.
Yalla, Masalam. Allah barik.
Okay, thank you.